Alrighty, so let's take a look at another problem. Hello and welcome, or welcome back. Yeah, this problem, I think, I haven't looked at it yet, but I like to take a few minutes, not a few minutes, a few seconds, like half a minute before I start into the problems, and just kind of hang out and chat for a bit. Not chat, but just say hi. Yeah, man, I'm watching all these videos. The soft white underbelly. Watching all these videos, and it's very interesting. What am I looking for here? This one, okay. Yeah, watching all these videos of other people and their lives, and I'm just grateful. I'm doing okay, you know. I'm doing okay as far as I can tell, as far as I know, I'm doing all right. Okay. Design an algorithm to encode a list of strings to a string. The encoded string is then sent over the network and is decoded back to the original list of strings. Machine 1 sender has the function, Machine 2 receiver has the function, Machine 1 does encoded string encode, Machine 2 does decode encoded string. Strings 2 in Machine 2 should be the same as strings in Machine 1. Implement the encode and decode methods. The string may contain any possible characters out of 256 valid ASCII characters. Your algorithm should be generalized enough to work on any possible characters. Do not use class member global static variables to store states. Your encode and decode algorithm should be stateless. Do not rely on any library methods such as eval or serialized methods. You should implement your own encode decode algorithm. That's kind of nifty. A list of strings to a string. The encoded string is then sent over the network and is decoded back to the original list of strings. Oh, okay. That's kind of neat. Is it supposed to be compression, encoding, or encryption? Because these are all different, right? A compression is not supposed to be, I guess, unknowable, something like that. In other words, the encoding for a compression, I guess encoding is compression. You should be able to decode it without, it's sort of somewhat publicly. Publicly, you can decode it. What you would normally do is you would compress and then encrypt, and then send the encrypted compressed version over. Then it would be decrypted and then decompressed. So I guess encoded and decoded. The codec object. Yeah, that's interesting. Super interesting. This is actually a very significant question here because there's sort of like layers of interesting things going on here. This is one of those questions that, so like in finance, you have this thing called the FIX protocol, Financial Information Exchange, and it's a protocol from 1992, so pretty old, where you can trade, basically you can trade assets digitally, and it's a protocol to enable that. The idea, I'm not gonna get too far into FIX protocol, but it's kind of it's sort of a type of encoding. The protocol, you have some information and you send it sort of in a certain way, and then it's basically translated to a fixed message. Now here's the thing, the actual data, like there could be layers of stuff in between. The actual data could be encoded and compressed a different way. but it's sort of like the information with regard to a certain transaction is sort of that's sort of one layer of encoding where it's encoded into the fixed protocol, fixed message, and then that's sent over the line, and then once you get your fixed message, you sort of it's actually sort of a layer of abstraction above a lot of other things because it's actually human readable. It's sort of like from a human understanding to usually it's tag value pairs that have meaning, and then obviously you'd have different layers of stuff going on between there. Like you might have another compression, what do they call it? Compression algorithm, and then you'd have an encryption algorithm, and then you'd have on the other side decryption, decompression, and then the human might read the fixed message, or usually the fixed message will be read by a machine, which can then translate that to some kind of meaning. So actually, I don't know, but that's I guess this is even lower level than that. This is like really any kind of compression you might want to do, I suppose. But one really simple algorithm to do this would be take every string. Well, you got to be careful because you need. No, I was gonna say just put a separating character between every string, and then your decoding would just separate on that character. However, you have a problem with that because you don't actually know where the ending of the string is going to be. That's an interesting question. I like so the kind of neat compression I've seen, very simple compression I've seen with strings is you take each character and you say, okay, however many characters come after that, I'm going to add a number. So I guess if there's no number, well, actually you have to be careful because that doesn't work really either necessarily if you're dealing with strings that have, this is any character set they said, right? So you could have numbers in there too. So actually in that case you would want to do you have to be very strict then. What you'd have to do is, it might not actually compress anything. What you would do is you'd say, okay, if you see a certain character duplicated a few times, which is kind of rare, but you would take that character and compress it to 2 characters and say the first character and then how many times it shows up. You actually have to be very strict if you're having an open character set, a very large open character set, I guess. Because if you include numbers, yeah, no, I don't think that's actually a good idea because it's kind of rare that you get, like, you don't really get a great compression if you do that anyway. If you write some text, it's kind of rare that you have the same character written twice in a row or multiple times in a row. Yeah, I don't think that's a great way to compress things. I don't know. I'm not really familiar at all with encodings. Like, I don't know how do you typically encode a string? I mean, I want to say you can like have a very specific sequence of characters at the end, and then that would represent, the character that sort of terminates that string. I mean, I've actually seen something like that where you use like the null character, basically, something like that. I don't know if you can. Just want to see here. Any possible characters? Valid ASCII characters. I mean, that's like a really simple way to do this. Is just use like a null character. So there's 256. There's only 127 here. Just thinking. 256. How do you get 256? One, two, three, 4, 5, 6, 7. I'm looking for 256 ASCII characters. That doesn't seem right. So American Standard Code for Information Interchange. That's ASCII. Extended table, okay. Windows, superset. Oh. Okay. Interesting. So use that last bit for other characters. Extended set. So there's just no symbol for some of these, right? Non-breaking space. So some of these are empty, right? Like that's actually what I'm trying to do. What I'm looking for is to use one of these empty characters in the ASCII set to represent a basically a separation between the the strings. Ideally, that's what I'd like to do. However, I'm not sure if I can do that. Empty ASCII code. It says all 256 characters. Extended ASCII, okay. Okay, yeah, it's really confusing. I was always confused by what is meant when people are talking about ASCII codes and extended ASCII codes and all that. So really it's 7 bits, and the other bit is used for who knows what. But there's there are extensions. So Windows uses an extended ASCII. Alright, what I'm looking for is multi-byte character encoding is also true extended ASCII. That means all ASCII characters are encoded with a single byte, same value. Text in other languages can display as Mojibake. Oh, I've seen that. I've seen that. It's always funny. You interpret with the wrong encoding. That's super interesting. Okay. Anyway, alright, I don't think it's really gonna help answer my question. I was thinking you could find some character sequence that doesn't exist in the strings and make that a keyword to separate each string. The longer that string sequence is, the more likely it is that it won't exist in one of the strings that you're given. That's not a very good way to encode things. Alright, so I gotta think about it for a while. I don't actually know. Yeah, that's interesting. So here's the deal. I want to basically just take these strings, concatenate them, and just specify a way to identify the take these strings, concatenate them, and specify a way to identify. How do I say this? Take these strings, concatenate them, and specify a way to Oh, that's pretty easy. Actually, that's an easy way to do it. You just add a header. Right, I forgot. Yeah, that's what you do. I forgot. When you send messages, you just use headers. So the decoding is just going to modify the header. Completely forgot. Yeah, that's a very standard thing when you're dealing with messaging. Actually, if you look at the RFCs for the internet, you'll find headers for messages are pretty common. So basically, we can make the headers specify how many strings there are and how long each string is. Like, so it'd be a sequence of lengths. So first is the number of strings, and then the next is the sequence of lengths for those strings, and then the data will just be all the strings, concatenated. Now it would be interesting if there were a way to compress the string. So use like an XOR function or something, like something that modifies the bits, so you can actually expand the bits, if that makes sense. You may be able to do it that way. Actually convert the characters to bits, and then take that bit sequence and shrink it down to, or even convert the characters to. Oh, that's interesting. You could even convert the string itself to a number, like to bits, and then to the number generated by those bits. I don't know if that's better. That's a really big number. That's a really big number. Like, we're getting into compression here. But yeah, I mean, you could take that number and then convert it back to the string form. I don't know, if you had a number that was like, how big is, it's definitely easier to use, to do it with a string. Because every character is 32 bits, right? So 2 raised to the 32nd is huge, right? It's a gigantic number. So we would need all of the bits to represent that number, right? I could reinterpret all of those bits as characters and then do compression on large sequences of zeros and ones. But I don't think that really saves you very much. I don't think you really get much for compressing it like that. I don't think so. Because you just doubled the size of the thing by 8 anyway. I don't. I don't know. How do you compress strings? Can you really do that? That'd be pretty neat. That would be pretty neat if there was a way to. I want to say something like some kind of mathematical function that'll actually give you that number, if that makes sense. That would be really interesting. If you interpret the whole string as a gigantic number, and then you have a mathematical function, like a state machine or something. Like that. Okay, so that would be really interesting. If you could create like a state machine that would, like a mathematical function that would actually pump out each character in the string, like when you run the function, and then you just have some parameters to actually run the function, and that's like part of the header, and that'll actually generate the string. That's like a super interesting way to compress a string. I wonder if that's that would be really interesting. That would be an interesting kind of project for like machine learning software, because basically machine learning software is like learning a function. So if you could learn a function that would generate a string, just like a specific function that generates a specific string, and each value you give to that function generates the next character, and so you just need to know how many characters you generate, and then it'll generate that sequence of characters. That's like, that would be pretty interesting. That would be really interesting. I guess it'd be like a polynomial of some kind. Problem with that though is, I think all the parameters to the polynomial, you would need as many parameters to the polynomial as you have characters in the string. Like, is there really a way to do that? Is that really possible? Removing unnecessary information over that's being sent. I don't know. That's a pretty neat idea, though. I like that. That's a very interesting idea, concept. Maybe use machine learning to encode, to do compression. I don't know. Anyway. I think in this case we'll just create a header for our string, and that's it. Keep it really simple. So, I mean, I guess that's also interesting too. It's like our header doesn't necessarily need to be a fixed size. It could just be literally a number, which is the number of strings, a space, and then every number after that is the size of the string, and then the rest, all the data is just the concatenated strings. I think that's enough. That should be enough. So let's do it that way. All right, so do it that way. I mean, that's one way to encode multiple strings. This is a really interesting question. Probably not the best way to encode, but that's basically what an encoding is. It's got like a header that specifies how the data is going to be sort of mapped out. It's pretty much what most encodings are, I guess. So now the question is, how can you break this? Well, you could break this by, well, no, it could be, yeah, it could just be gigantic. It doesn't matter. The numbers themselves, you can interpret these numbers as big integers, I guess. Yeah. So just thinking, how do you store big integers? Let's just suppose that the size of the strings are going to be not too large. We'll just suppose that. Be reasonably large, but in theory you could actually make these, you could break this by making the sizes of the strings so big that that doesn't fit in the encoding, if that makes sense. That's a possibility. But anyway, yes, that's going to be our encoding. And we'll say int n is going to be strings.size, and we're going to say what's a ret? We actually want string stream. So concatenate. Yeah, actually that's it, really. Let's keep it kind of simple. And then no spaces. No spaces. Yeah, no spaces. Number of strings, space, each size of the string of this, each respective string, one space, and then the whole thing concatenated. Excuse me. And then decoding, you're going to don't need to destroy the string. Don't need to modify this either. you're going to retrieve the first integer string, which is going to be, we're actually going to use an iterator here. We're going to use a regex iterator. I like this approach. So we're going to split on space characters. There's actually, let's not use regex for this. This is probably, yeah, it's probably a way to do this. So we'll do for int I equals 0, this.size, character C equals s of I, and we're going to say can do it this way too. Let's just say P for position. So, and we're going to say int n equals 0, and we'll say if P, or if C is not equal to this character, then we're going to take n and multiply it by 10 and add C minus 0. Interpret C as a digit from a number, right? And you really don't, yeah. Excuse me. So first integer of the string, do that, and then now we say int I equals 0, I is less than n, plus I. We're going to say another loop, basically the same loop. Where we say what we do, so P is incremented past this value. Same thing, P less than size, S of P is not equal to space character. You want to increment P, set S equal to S of P. If it's not equal to this, then we have another, so this next integer, string sizes, and once we increment P, so we have next size equals 0, instead of n, we're going to have next size. And we say take string sizes, push it back, at next size, right? And yeah, we do that a series of times. And P should be, at this point, you're actually going to when C is actually equal to this character, you're going to increment P. Now here's a tricky thing. Where is P and when does it stop? So when S of P is not equal, So actually, you want to say p minus 1. Right, because you actually want to, you actually don't even care about these things. If s of p is equal to this, then you won't even, you'll just exit the loop. You won't even get this far. So you don't really need that. You do, however, want to increment p. Scroll past. Yeah. There you go. Okay, that makes sense. Now, retrieve the rest of the message. This is a really interesting question. I like this question a lot. This is cool. This is cool. You want to say something like this. How are we doing here? Yeah, we'll use a string stream as well. So next size, and we're going to say really it's, and we're going to have another int j equals 0. J is less than next size. I'm going to increment j and p. And you're going to say s of p you're going to say string stream c, make it empty the string stream, get those characters, push back that string stream to our return vector, and then get the next size, get the next number of characters, keep incrementing p. That's really it. It's, yeah, that's pretty much it, actually. What happens if we compile? Oh. You need to have loops need to be set up properly. Sizes dot sizes. Sizes dot sizes. Hey, it worked. Neat. Cool. Kill. Kill. Okay, when I saw this problem in the past, and I really did not understand it. I didn't get it, and I didn't get the right answer either. I think I just skipped it. I forgot what I did, but there's actually a really relatively simple question, a great question, an important question, and a fun question. Yeah, this is definitely a question that I'm glad that we went over. It's basically this idea of adding headers to messages in order to organize the data. That's pretty much what a codec is. It's literally just a header, and if you know what the codec is, and your machine is set up to process that codec, then it can process that header, and then it can interpret that data a certain way, and then you're in good shape. And you can send messages back and forth with, interpreting the headers the right way so we understand we can basically understand the message. Yeah, otherwise what are you doing? Otherwise you just get a whole bunch of characters and you're like, I don't what do I do with all these characters, man? How am I supposed to interpret this? Let's go with a bunch of stuff. Just a bunch of things. Just A, B, C. Let's get some degenerate cases in there. There's nothing. One empty string. 2 empty strings. 3 empty strings. 3 empty strings and then something. Something, 3 empty strings, and then something else. And then another empty string. Something, a bunch of empty strings and nothing else. Oh, it's correct for all of them. No kidding. And how about, oh, wait a minute. What's going on? This bad habit of hitting buttons I'm not supposed to hit. Easy as 1, 2, 3. Bum, 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 bum. All of these are right. Are you kidding? Really, we got all of them right. How do we do that? Really? Really? How did we do that? Yeah, I guess so, right? Because we have an empty string. Yeah, our string stream is an empty string, so that's pretty neat. Yeah, we handle the empty strings correctly. Wow. Oh, no kidding. Okay, and let's put a bunch of junk in there. Let's make it kind of crazy. Let's get wild, man. I don't know. I don't know what we can do. Try to trip it up. Let's go for it. See what happens. Hey, works. Sweet, sweet, awesome, nice. I like that. I like that. Boom, 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 no, 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 no. Oh, I feel like a genius now. Let's actually look at the discussion. How long did that take? Oh, we were looking at that for almost an hour. Wow. Yeah, okay. That's a good discussion. It's like super simple encoding, but all right, C++ solution. This doesn't work. It's wrong. Oh. Oh. Well, you don't need that anymore. If you know the length. Wait, what? Get the length, the @ symbol, and the whole string. Oh, I see. That's interesting. Oh, I could have done it this way. That would have been so much better. What I did was kind of not that good, actually. What I did wasn't that great. Okay, so yeah, okay, you can okay, that makes sense. So if you, you don't have to use a header. You could use a different kind of approach. So, length plus a separator plus a string. Wow. Wow. That's a good one. I like that. That's a good way to do it. That's a good way to do it. I didn't think to do that. Yeah, I get it. So, because you start off at the front with a digit and then an @ symbol, that's sort of the beginning. That repeats. That repeats nicely. You know how many characters. It doesn't matter what's in the string after that, because you're just gonna count the number of characters and take that, and then you get the same situation repeated again. So sort of by induction, you can just concatenate it all that way, and then that works. That's really interesting. You don't even need an @ symbol. You can just do a space. You can use whatever character you want. Just basically a spacer character. So the length, spacer character, the string, and you have that repeated over and over. And when you decode it, you just pull the character, or pull the integer, remove the spacer, pull all those number characters, and then repeat until basically the string should be empty after that. There should be no extra characters at the end. Actually, you just throw out whatever's left if there's anything extra in the string. Somehow, any extra garbage got thrown on top. Just toss it. Same idea, but a little different. That's super smart. iString stream. Oh, I should use iString stream a little more frequently. I like that. I like that approach. The iString stream. Move the resizer string. Get the front. Get the length. Remove the dummy character. Resizer string the length of the string. Read into your string the length, and then push back the string. I like that a lot. This is just O of 2n, by the way. This O of n times m is not correct. It's true that this is going to be called for each string, but the size of the string is O of n, right? So it's just 2n, O of 2n. So this is faster than doing this. This isn't really that much faster though, these things, because you have to dump all of this whole string into a string stream anyway, and then you also need to dump part of the string into another string, which then gets pushed back into the result vector. So there's a lot of stuff going on, we'll just say. Yeah. Personally, I like looping through the string the way that I did it, instead of like initializing a string stream. And then, I mean, this is like very concise and legible, so maybe this is better, but it's a little bit more efficient, I think, if you, actually I don't know if it's more efficient. I'm not really sure. Not even sure. I don't know. But anyway, I like this. It's a good way to do it. Glad I looked at the solutions too. Job with escaping. Java. So he used this spacing character. He did the same thing. He just did he used a special string formatting here to create a list comprehension, and then joined on list comprehension. So what this will do is it'll take this %d is the string, the length of the string, and then you're going to append. So you're gonna get this plus s, which is just the length of the string and a colon, and then so basically it's the same thing. Just every string separated by a colon and the length of the string, and then when you decode, this is interesting. How does he do this? Strings I is 0, I is less than length. Set j to find this colon. I is going to be j plus 1 plus int of. So interpret this as an integer from I to j, right? That section. And then I is going to be, you're going to update I from j, and then you're going to append that section. And then I is already updated past the, it's already updated the right spot. That's pretty interesting. So you kind of swap j and I in terms of their positions. And then this should hit the end of the string. That should be that. Neat. Neat. Now this, you could have a problem though if you have garbage thrown in at the end of your string. Like if your data gets corrupted somehow along the way, and you so I guess there's two things. Like, I think the approach that I gave handles corrupted data a little bit better. Because like every loop is closed, sort of. Like those conditions will always be hit even if there's corrupted data. Whereas this is actually, you could have a problem with your corrupted data where, where you never find the end of the string, something like that. if j goes to -1, and then you're in a really awkward spot. And then who knows what happens. Excuse me, I don't know. I actually don't know. I'd have to like run through some test cases to see if you had like missing certain parts of the what your expected string. But this is really interesting. Yeah, it's definitely very interesting. So this is incorrect. Incorrect. And the reason is that you're imposing an integer and this character in front of every string. So it's always going to be that in the beginning. So it's not true that this won't work. But this is a very upvoted question. It's an important question. That's a bad answer. Wrong, it works. Why? Because it looks nice and appropriate. Bad answer. Character 257. That's interesting. I guess you could. Oh, actually, I didn't think about that. Yeah. Well, no. Can you do that? No. You can't, right? What's 257 as a character? No. I don't think you can, right? Because we do 1, 2, 3, 4, 5, 6, 7, 8. 8 bits that are ones. That's a geometric sum, 2 to the 0 plus 2 to the 1 ... plus 2 to the 7th. All right, sum from I equals 0 to the 7th of a geometric series 2 raised to the I. And those are, it's 2 raised to the 8th minus 1 over 1. 2 raised to the 8th minus 1 over 1. 2 raised to the 8th minus 1. Yeah. That's the largest number you can represent. So this doesn't fit in a single character. This is now multiple characters. What is that? What does that become? I don't think that's right. I don't know what that is. That's definitely not. I mean, not that this is wrong necessarily, but it's a little confusing. I don't know what this will do. I have no idea. I want to say this gets interpreted differently than what we're expecting, because it doesn't fit in a single byte character. Yeah, I don't know what happens here. That is interesting though. It's an interesting answer. Well, the reason I don't like this answer though is that this works anyway. Doesn't matter. I like this. Similar one. Put all the sizes at the beginning and put a dot between each size, and then a space to indicate the sizes are over, and the actual strings start. Interesting. Yeah, I did the same thing. Or I did a similar thing. Very smart solution as always, yeah. Boom, 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 boom. So special they made it a hard problem. Oh, this used to be a hard problem. This is not a hard problem. Not anymore. But no, that's not what it does. It would take hello, which is 1, 2, 3, 4, 5, and it would put 5 in a spacer. Wow, that's really good. I like this. This is a really good question. I'm glad we did this question. Glad we did it. Definitely could make mine better though if we used similar. Yeah, it kind of took a really long time to write this up, huh? I didn't really understand the question too. To my defense, in my defense, it took me a while to really understand what they were asking. Huh. Interesting. Interesting. All right, let me end it here. So yeah, thank you all for watching. Appreciate it. I will talk to you all soon. Have a good rest of your day. The plan is I'll go ahead and end the stream here, so the VOD is sort of done, and then I'm going to look to do the next thing, which I don't even know what I want to do next. I think take a break. Yeah, take a break for some time. Just hang out. Probably pick up another problem. So yeah, thank you for watching. Take care.